This week we made our first direct contact with one of the most elusive objects in the solar system, a comet. On Wednesday, the European Space Agency's robotic lander called Philae landed safely, eventually, on the surface of the comet CHURYUMOV-GERASIMENKO, also known as 67P. The 100-kilogram probe has since sent back to Earth the first ever photos taken on the surface of a comet. And with its barrage of instruments, we'll now study its composition, including how much water and organic compounds it's carrying. Things didn't go exactly as planned during the landing, but in space exploration, they rarely do. And really, it's amazing that the probe even got there in the first place. This mission began 10 years ago in March 2004, when the European Space Agency launched the ROSETTA spacecraft, which carried Philae and a whole suite of instruments 500 million kilometers to rendezvous with 67P. The challenge, though, was that no rocket is powerful enough to send a spacecraft all the way to a comet on its own. So Rosetta had to perform 3 flybys of Earth and 1 of Mars, using the gravitation of the planets to build up momentum and speed like a rock leaving a slingshot. With this help, Rosetta was able to pass Jupiter's orbit early this year, having gained a speed of 60,000 kilometers per hour. This summer, Rosetta closed in on 67P and became the first spacecraft to orbit a comet, keeping a distance of about 30 kilometers while it began taking in all kinds of new data. First, it took spectrographic readings using a NASA instrument called ALICE, which detected hydrogen and oxygen in its atmosphere, and discovered a few surprising things about its appearance, including a lack of visible ice and a strikingly dark color that may suggest lots of complex organic compounds. Then another instrument, ROSETTA, used mass spectrometers to detect other compounds in the comet's atmosphere, such as ammonia, methane, formaldehyde, hydrogen cyanide, and sulfur dioxide. This led scientists to suggest that the comet probably smells like pee. And finally, on Wednesday, history was made when Philae became the first spacecraft to land on a comet. And much in the same way that getting to a comet a 500 million kilometers away took some brilliant physics, landing a tiny probe on a rock 3 kilometers wide was no small task either. First, scientists had to choose a suitable landing site, which was tough because 67P's surface is littered with boulders and crevices. Philae needed a relatively smooth surface with enough light to charge its batteries using solar energy. And since the comet's gravity is weak, Philae was supposed to release harpoons from 2 of its 3 feet to anchor it to the surface. But shortly after the landing gear had deployed and Philae was ready to land, the harpoons failed to release. After touching on the surface, the lander began to gain altitude again. Philae actually bounced off the surface of the comet at first and spent almost 2 hours in space before touching down again a kilometer away from its original landing site. Then Philae bounced slightly again for about 7 minutes, landing finally a few meters away. ESA researchers aren't sure where exactly on the comet Philae is now, but they know that it is there because of the photographs it sent us. The images show Philae has landed next to a tall cliff, which unfortunately puts the lander in shadow for most of the comet's rotation. Figuring out how to charge Philae's solar-powered batteries will be a challenge, as will making sure each of its 10 instruments is used safely. Since the probe is not anchored on the comet, any sudden movement could knock it off the surface again. But scientists have big plans for this little guy. In the coming months, it'll be studying the comet's composition using X-rays, radio waves, and sound waves. It'll measure its density, temperature, and magnetic field. It'll even drill into the surface, collect samples, and analyze them. And of course, take tons and tons of pictures. Philae will transmit all this data from the comet to Earth via the Rosetta orbiter. And astronomers are on pins and needles to get it, because 67P hails from the Kuiper belt, the ring of icy debris past the orbit of Neptune that dates back to the origin of our solar system. So the closer we get to these objects, the closer we get to understanding our astronomical history. As 67P approaches the sun, Philae will eventually stop functioning, but Rosetta will continue to orbit the comet as it makes its closest approach to the sun in August of next year. Then the comet will begin its departure from the inner solar system, and Rosetta will continue to accompany it until next December, when it'll once again pass by Earth more than 10 years after it began its journey. Thanks for joining me for this very special episode of SciShow Space News. If you want to keep exploring the universe with us, check out subbable.com/scishow. And don't forget to go to youtube.com/SciShowSpace and subscribe.